All right. So, let's talk about functions. I hate these things. Okay.
I did this for you.
Good. I just want a list of things you're in. Don't care about any of that. Just tell me things that you're involved in, and I will write the letter.
My third hour can help.
So, oh, thank you. Okay, now, now you know why. Well, those letters that the counselor has to fill out, it doesn't tell you anything about the kid. So I'm like, why would I want that thing? To me, it's worthless.
Oh, is that what you were going to turn? No. What was that for, Miss Sam?
I don't know, some scholarship.
Was it for a Buick scholarship? You know.
Oh, I don't know.
Buick
See, that's what I mean. It doesn't even say that.
So it's...
letter does. Buick scholarship does.
Okay, that's what I didn't think so, but I only got like half of it does. So yeah. It doesn't.
Okay, I don't think it requires that. No, but that thing, it says like, what are your parents? Something.
Oh yeah.
And all this stuff that is, I could care less. I mean, tell me what you do.
Oh, for like Buick scholarship.
For to get a letter of recommendation. I mean, some form the counselors have that I hate. Okay, X's. Domain are X's that work in our equation. Range. Y's that are possible answers in our equation. Okay, domain and range. Let's start over. As if we weren't rudely interrupted. Okay, now, functions. Let's review them. Step 1, domain. What's domain? Domain are x's that work in our equation. Range. Y's that are possible answers to our equation. So, we have f of x, which we know is y. We put things in, that's the domain. Things come out, the outcome is the range. Okay? Now, if I had f of x equals 3x squared plus 2, and g of x was equal to x squared plus 2x plus 5, say. Okay, step 1. What is f of 1? Right, 3 times 1 squared plus 2 is 5. Okay, who can tell me what g of 2 is? 2 squared plus 2 times 2 plus 5 is 13. Okay, how about f of x plus g of x? Four x squared plus 2x plus 7. F of x minus g of x. 2x squared minus 2x minus 3. Good? Okay, how about f of x times g of x? 3x squared plus 2 times x squared plus 2x plus 5, right? Okay, so I say 3x to the fourth plus 6x cubed plus 15x squared plus 2x squared plus 4x plus 10. I add them together, I get 3x to the fourth plus 6x cubed plus 17x squared plus 4x plus 10. Good? Yes? Okay, how about f of x divided by g of x? 3x squared plus 2 divided by x squared plus 2x plus 5. Provided what? X squared plus 2x plus 5 doesn't do what? Doesn't equal 0. How could I find out where that guy equals 0? Set it equal to 0 and use the quadratic equation. And we say negative 2 plus or minus square root of 2 squared minus 4ac over 2 times a. Negative 2 plus or minus square root of 4 minus 20, negative 16 over 2. Is this going to be equal to anything? Well, it's going to be negative 2 plus or minus 4i radical over 2, rather, 4i, so we get negative 1 plus or minus 2i. So these are imaginary. Okay, so there's nothing that's going to make this imaginary, so this is good, right? All right, how about Bog and Goth? All right, if we have f of g of x, Bog, or we have g of f of x, this is a composition, right? Okay, now, no problem, right? We get that. Alrighty, so how about if I had if f of x is equal to 3x squared plus 2, and this time g of x equals 2x plus 6, what is f of g of x? 3 times 2x plus 6 squared plus 2, right? So we have 3 times 4x squared plus 24x plus 36 plus 2. So we have 12x squared plus 72x plus, what's that, 108 plus 2. So somebody else see if they get 12x squared plus 72x plus 110. Yes, no, maybe so. Okay, how about g of f of x? 2 times 3x squared plus 2 plus 6. 6x squared plus 4 plus 6 is 6x squared plus 10. Okay. Okay, let's talk about inverses. How about if I have how about if you had this? You have 1, 2, 3, 6, 9, 8. this is your function. What's your inverse? 2, 1, 6, 3, 8, 9. Okay, how about if my function had a domain of 0 to infinity and a range of 1 to 9? What would the inverse have? What would his domain be? 1 to 9, and his range would be 0 to infinity. All right, but how about if I had we had y equals 3x minus 2? That's f of x. And I want the inverse. What do we do? Okay, switch x and y and solve for y. Okay, so I have x equals 3y minus 2. So I have x plus 2 equals 3y. X plus 2 divided by 3 equals y. Good? We're happy with that? Okay, so this is the symbol for inverse. Okay? Symbol for inverse. Now, how on the AP test, thank you, ma'am. How on the AP test do I prove to them I have an inverse? Okay, this is what you do. F of f negative 1 of x and f negative 1 of f of x. Let's see what happens when we do this. If I had the original, this is my original, so I have 3 times x plus 2 divided by 3 minus 2. So, what do we get? What do we get for the answer for that? X. Alright, now, what if I put in my original, which is 3x minus 2 plus 2 over 3. I have x plus 2. I put my original in there. What do you get for this? X. If f of g of x and g of f of x both equal x, they are inverses of each other. That's how you prove that. Okay, and they have asked that on an AP test before. Are these functions inverses? And kids are like, they left it blank. And all they had to do was fog and goff to it to decide they were. Okay, I mean, it's something easy. But it's like, if nobody shows you that that's what happens, you're like, oh, well, I don't know. And you can't just put 5 in there. You know, you can't just put a number in and do the inverse thing, because then you've only proved that 5 works, or you've only proved that 6 works, or something. You know, you've got to prove it for x. Okay, good deal. Yes? What's the matter?
I just got one.
Oh, okay. All right, how about odd and even? Had that back in it. Here's the back end. I threw it. I remember that. Okay. This was last hour, yes. Okay. See, this pen is thicker. Odd function. Odd function. Talk to me about odd functions. What are odd functions? What are they? They're odd? Yeah, okay. Symmetric with what? with the origin. Even functions. Symmetric with what? With the y-axis, okay? Odd functions, even functions. Okay, typical odd functions that you know. X cubed, tan x, sine x. Okay, these are all odd. Even functions, you know. X squared, cosine x. Those are both even. These three are all odd. Just, for reference of in your brain, what they could look like. All right, now, how do I prove this? This is f of negative x equals negative f of x. This one is f of x equals f of negative x. Okay, if you are symmetric with the x-axis, you are not a function. Okay, remember, if you are symmetric with x-axis, not a function. Okay, remember, these are like parabolas that go like this. Remember that test you used to do? Okay, not a function. Okay, let's talk about, is this function odd, even, or neither? F of x equals 3x squared plus 2x minus 3. Odd, even, or neither? Okay, if we wanted to test odd, we would say f of negative x equals negative f of x. So I have 3 negative x squared plus 2 times negative x minus 3. Is that the same as negative of 3x squared plus 2x minus 3? This is 3x squared minus 2x minus 3. Is that the same as negative 3x squared minus 2x plus 3? No. So, this is not odd. Okay, even. F of x equals f of negative x. 3x squared plus 2x minus 3, is that the same as 3 times negative x squared plus 2 times negative x minus 3? Is correct. 3x squared plus 2x minus 3, is that the same as 3x squared minus 2x minus 3? No. So this is not even. This is a neither.
Yes.
It's a function, but it's a parabola as a matter of fact, but it's symmetric over whatever line that is going through its vertex. It's flipping over that. Okay? So, we have to, much better.
Yeah. People play athletics.
Oh my gosh.
Math's genius. Just the basics.
Okay. Anyway, tomorrow we're going to talk about horizontal asymptotes, vertical asymptotes. We're going to keep going, and then I'm going to give you a packet to class. Okay.